Hello, my dear students. Welcome back to the lecture. So in this lecture, we will understand how to take the levels at the site with the help of AutoCAL. So far what I told that we understood how to take the breadth, we understood how to take the length. And also we saw from the drawing that this is a depth of the excavation that we are supposed to do. But how do you determine this depth? What is the instrument that you're going to use? Whether you make use of a tape or whether you have any certain instrument through which the level can be defined, we'll try to see that, right? So before that, we need to understand that all the construction project will have a permanent benchmark taken from the survey department or from the local authority. Keeping this reading, all of the levels are taken on the construction project for marking the levels. That means, see, usually if you take up any construction project, we'll be setting up a temporary benchmark. You can see something is written here. TBM stand for temporary benchmark, and then written something that is 3.357 meter, whatever it may be, right? So we want certain temporary benchmark to be set up in a particular project. Now, how do you do that? How do we get this temporary benchmark? We'll try to understand. So before understanding the temporary benchmark, we have something called as permanent benchmark. So I'll first explain you what is this temporary permanent benchmark. If you have visited to any of the railway stations, right, what will happen? You can see it's written New Delhi, and what is written here? Mean sea level, that is 214.42 meter. That means this New Delhi city is at a mean sea level at a height of 214.42 meter above the mean sea level. In the same way, if you come to Bangalore city, it is written MSL, that is mean sea level. It is 896.920 above the mean sea level. Now, what exactly is this mean sea level? See, suppose if I ask you, what is the height of this plane, then how you are going to tell me, right? So, for example, I asked one person to tell me the height of this building. He told me with reference to the top of this mountain. Let me tell, with reference to the top of this mountain, he measured and told me that this is the height of the flight from that mountain, and let us say it is some 200 feet. Okay. Now I asked another person, tell me the height of this particular flight. So another person told me from with reference to this particular mountain. You can see a small thing from here. He measured it and he told that the height of this flight is 350 feet from here. Now, if I ask another 3-4 different people, based on where they are standing, they are going to tell me the height of this particular flight. But that will not work out for me, right? I want one particular benchmark, or I want one particular level from where all my measurements will be done. So that is why the concept of mean sea level comes into play. That means, so this is a sea what I have, right? So every time what will happen, due to the waves, the sea will try to, this is a kind of a wave what we try to see in the sea, isn't it? Now we have taken an average of this. So this averages and all this will taken by the survey department and all. So once in 20 years, they are going to measure that what is the average sea value and all. Okay, what is the average sea waves that we have got, and based on that, all these calculations will be done. So one thing we are going to take an average of this waves. Okay, and with reference to this, we are going to tell all the distance. Now, after doing that, we got one mean sea level, so that is called as MSL. Now if I ask you, always I'm going to measure from here itself. Always I'm going to measure from here itself. So this is my mean sea level. Okay, and now if I ask you what is the height of this flight, you're going to tell from this mean sea level, it is at a distance of 5,000 feet above the MSL level. That is, what is that? This particular flight is at a height of 5,000 feet MSL, that is mean sea level. In the same way, if I ask you what is the height of this particular hatch, that is the boat is here, the top of this, if I ask you how much it is, again you're going to measure it from the mean sea level. From the mean sea level, it is at a height of 3,000 feet. Got it? So this is a reference level. In the same way, let us say I have one small building here, a kind of a building here. Let us consider. Okay. Now, if I ask you, tell me the height of this building, again, you're going to measure from where? From this mean sea level, you're going to measure and tell, okay, this is the height of my building. Got it? So this mean sea level will act as a reference for me. And from here only, all the railway station marking what they have given, no, that is taken from here. Got it? So that is why I had shown you this. That is, it is written. Now, now you understand what is this 896.920 MSL. That means this particular Bangalore city, that is at the railway station point, what we have, it is at a height of 896.920 meter from the mean sea level. Okay, so that is how you have to understand it. So now we understood all these things. Now how do we carry this mean sea level? Because see, this mean sea level, whatever RL we have, that is reduced level we have, it is at the different, it is in the railway station. Now let us say the site what I am doing, it is, let us say 100 or 200 kilometers far away from the railway station. So in that case, how do you take care of this? I mean, how do you convert, how do you transfer this level to your particular site? These levels can be carried to a particular site either by leveling instrument, that is with help of an auto level, or even total station can be used, or with help of a satellite. So with the help of a satellite, we can try to do all those things. That's the one way. Second is that these levels can be taken even from a nearby government inspection bungalow or from the road level. Once these levels are carried, we will establish the permanent level of this on the site. That means you have two options. Either you can carry this level from the railway station to your site, that is one way of doing. Otherwise, usually there's something called as inspection bungalows. If you are in any of your city, we have IB, which is called as inspection bungalow. So since it's a government bungalow, even that particular bungalow will be having certain RL. Okay. In the same way, the road level, you can see these are my road, isn't it? Even the road is going to have certain RL. So we can take that as a reference level, and from that we can establish the permanent benchmark, or let us say temporary benchmark onto a site. Got it? So again, it's written TBM 100.0 meter. It has been carried from somewhere, and in this particular site, they have created a small, what I call this, a small kind of a structure, and over that they have written 100.00 meter, right? Yeah. Now this is how you carry it. Let us say you have a railway station or an inspection bungalow, and I've taken 896.920. So what is this 896.920? Let us consider I've taken it for the Bangalore city, 896.920, and I've written it here. Okay. Or if it is not railway station, you can make use of an inspection bungalow. Even on the inspection bungalow, they are going to write it here. Now this is my road level. Now I'll transfer this. Even I can transfer with the help of auto level. Now how do we transfer this? All these things comes under the scope of a surveyor. A surveyor is going to do all with the help of all those calculation, height and rise method, okay, backside, foresight, all those things we have to do. We'll not try to get into that, right? Yeah. So this is a road level, which is 96.9 meter. Now this is a particular site what I have. Now imagine this is a site what I have. I want to establish a temporary benchmark here. So whenever I do construction, no, whatever is my road level, 1 meter or 1.5 meter above that only I'll do my building construction. If you do at the same level, what will happen? Whatever water will come in on the road, the same will enter into your building. So we don't want that. Always whenever we do construction, we get the construction done at a height, at a more height than the road level. That is why you can see the level here, it is 96.9 meter, whereas when we transferred it to our site, I've taken it as 98.25 meter. That means almost 2 meter I've increased it from this particular level. Got it? So in this way, I will carry, and I'm going to establish this temporary benchmark. You can see why I have established 4 different benchmark here, because see, if it's a very big project, then it's difficult for me with the help of one particular temporary benchmark to carry it everywhere. Let us say this is my entire project. Got it? And I have a lot of footings everywhere. I have a footing here. I have a footing here. I have a footing here, here, here. Okay. All these are my footing. Now let us consider for this particular footing, I want to give the depth of the footing. So in that case, what I'm supposed to do, I'm going to keep my auto level here. I'll show you what exactly auto level looks like. Just till then, try to understand. So let us say this is my auto level. I'll keep it here. So I want to see this benchmark from here. So it's difficult for the surveyor to see the benchmark from here to here because it's a long distance. It's difficult. So instead of that, since this is a footing, I'm going to establish one temporary benchmark here as well, so that it is easy for me to see here, right? In the same way, if I want to give the depth of this footing, I won't be looking at this temporary benchmark. I'm going to look at this particular thing. In the same way, if I want to do a footing in this area, I'm going to look it in this way. So if it's a big project, we'll try to establish 4 or 5 different temporary benchmark at each of the corners, so that it is easy for me to carry out my surveying work. Got it? Yeah. So now we'll jump to this. What exactly is the auto level? So this is called as auto level. You can see this is an instrument what we have. So it's written auto level instrument, and this is a box of instrument. So to keep this, that is to balance this, we need to get a tripod. So this is called as tripod. Why it is called tripod? Because it is having 3 legs, 1, 2, and backside there's one more leg. So it is tri for 3. So it's a pod, tripod head. This is a tripod head. These are your adjusting clamps where you're going to fix the level, and this is a strap for you to carry, and this is a tripod with legs closed and carrying the strap. Got it? And this is a leveling carrying case. So this is where your auto level instrument is. Now this is how it looks finally. You can see this is how you kept your auto level. I mean, this is how your tripod looks. So these are the 3 legs, 1, 2, and 3, and these are the different names given to that. You call this as leg, this is called as pedal, this is called as sharp foot, then again this is called as belt. This is a mounting screw knob to fix your auto level over this, and this is a platform where you are going to keep the auto level. In the same way, this is how your auto level looks, and these are the different parts of that. Okay, so from here you are going to focus. This is your objective lens. From here you are going to focus, and from here you are going to see that. Sorry, from here you are going to from here you are going to see, and from here you are going to focus that. Then this is a sight what we have. Then this is the objective lens focus. These are the leveling screws. So these leveling screws will help us to make the level over this. Otherwise what will happen, it won't be horizontal, isn't it? To bring it horizontal, with the help of this we'll try to adjust it. So I'll show you a video for that, how the adjustment has to be done, and this is how it looks finally. Okay, now coming to the main part, this is called as leveling stuff, because we need to understand the reading, right? So this is the leveling stuff, it is called, and this is called as leveling stuff. It has got different heights. Like this leveling stuff is up to 4 meter. You can see 4 meter written here, and all these are the readings. In the same way, you get another leveling stuff which is 5 meter here. So in this way, 3 meter, 4 meter, and 5 meter are the different heights that you're going to get for the leveling stuff. Got it? Yeah. Now this is how it looks. This is a back side of that leveling stuff, and this is a front side of that leveling stuff. And you need to understand how to read this particular values here, and I'll be teaching you that how to read all this particular drawing, all this particular readings. In the same way, how it looks practically, this particular thing will go inside this particular thing will go inside this, and this is how it looks. So in actual, whenever you want to close it, this is how this is the actual size of that. But inside that, again, another part will be there. Inside this, another part will be there, and inside that another part will be there. Okay, so whenever you want to increase the height of this, you have to take it out so that you can see 1, 2, and 3. So based on that, whatever height is required, you can see one, they have opened it here, then they opened another one here, and in this way they have opened it. Got it? So this is how it has to be understood. Now coming to the reading part, see, one thing you have to understand, this is 7 meter. It's written 7 in the sense it is 7 meter. Okay, this is 7 meter. So 1 in the sense it is 7.10. So 7.10. Next, if I read it here, it is 7.20. If I read it here, it is 7.30. Then this is 7.40, 7.5, and 7.6. Got it? Yeah. Now let us say you have a reading something, this one. How do you read this? Let us say I want to read this particular. I got a line, or I got a level which says this is how it looks. Okay, then how do you read this? It's very simple. Try to understand. This is 7 meter, this is 7.1, and this is 7.2. Now this, each of this horizontal lines, what you can see, each of this is like so 1, 2, 3, 4, 5, isn't it? So each of this is 0.5 units. Each of this is 0.5 units. So if it is showing in the below portion, it is 7, 2, this is 0.1, it is 7.21 in this way. So it is 7.21. And then if it is in the bottom, it has to be odd number, like see 7.1 and 7.2. Up to here we are clear. If it shows here, it has to be 7.21. If it shows here, it has to be 7.23. If it shows here, it has to be 7.25. If it shows here, it has to be 7.27. That means 27, 25, 23, 21. That is 1, 3, 5, 7. That are odd. Those are odd numbers. In the same way, if it shows at the top, so here it was showing at the bottom. Here it was showing at the bottom. Now, if it's showing at the top, let us consider, then it will be your even numbers. That means 7.1, 7.2, 7.3, and it is 7.4 here. Got it? Now again, it is showing at the top. So again, it is 7.4 it is. So it will be 7.42 on the top. If it was below, it would have been 7.41. Got it? Next, again, it is at the top. So each unit is 0.2 for 7.42. Next is 7.44. Each unit is 0.2 now. Okay, let me write it here. See, this each unit, what you can see, this each unit, okay, from here to here. Okay, this is 0.2. I'll write it here. It is 0.2. If it's showing below, it will be 0.1. And if it is showing above the line, it will be 0.2. Got it? So that is how you have to read it. So again, now again, you see here, it is again at the top. So this is 7.4. 4, it is 4 here. 4244. This is 7.44. Next, this is 7.46. Suppose if it was here at the bottom, then it would have been 7.45 exactly. Then this one, it is 7.48 at the top. Suppose if it was at the bottom, suppose if I had to read this particular thing, then what it would have been? It would have been 7.4, 7.42, 44, 46. It would have been 7.47. But here it is at the top, so it is 7.48. Then it is 5, 7.5, and 7.6. Got it? So in this way, you have to understand it. Now, take this as an example and let me know what exactly this reading. It's very simple. See, 1.3 meter is here. This is my 1.3 meter. So this is 1.3 meter here. 31, 32, 33. Got it? Up to here, it is 1.33. If I go here at the top, it has to be 1.34. I'll write it here. See. So it is 1.3. We'll write in this way. It is 1.3. If I go here, it is 1.34. 31. Yeah, sorry. It has to be 1.31. 1.32. 1.33. 1.34. And this will be 1.35. Got it? Good. So now, where is that showing? It is showing at the bottom. This is the reading what we are supposed to look. So how much it will be? Up to here, it is 1.33. And this, if it is at the top, it would have been 1.34. We know that because you see here, this even numbers will be at the top, odd numbers will be at the bottom. So 1.33. So next is 1.335. Okay. So if it was at the top, it would have been 1.34. Got it? So that is how it is showing 1.335 here. Got it? Yeah. So this is how it looks practically. Look at this guy. He has fixed the tripod here. And from here, he is going to project it here. Whatever reading he is going to get, no, that is going to note down. For example, let us consider from here, I objected it here. I've seen it here. And let us say I got a reading. Through this, you have to check. And I got a reading of 1260, let us say 1.260 meter. So that is how you have to understand it. Got it? Yeah. Now, how do you take all this level? We'll try to understand. Usually, when we work in a bigger projects, in the drawing itself, all these things will be mentioned. That is, you can see a reference level from the ground level, that RL is 99.80. That means wherever you're standing, that is a ground level, that RL reduced level is 99.80. From where we got this? Again, we got all this level from the inspection bungalow, or let us say from the road we have taken. From the road, with reference to the road, I established this particular 99.80 on the ground level. It depends from place to place. Whatever is RL in your particular area, based on that, they have taken this. Again, the surveyor is going to give this. Got it? So this much is clear for us. And now this is a GFL level. GFL level in the sense, see, let us say this is my ground level. This is my ground level. Okay. This is a ground where I have. And above this, I want to construct a house. Above this, I want to construct a house. Above this, I want to construct, let us say this is my footing. Okay. Got it? Above this, I want to construct my house. Now, this 99.80, what you can see, that is this level. 99.80 is a top of your ground, normal soil what we have, that is your 99.80. And what is this 100.425? This 100.25 is a plinth top, the top of your plinth. See, usually we don't construct our house at the ground level or at the road level. We construct at certain height. So that certain height what they have taken is this much. From here to the top of your plinth, this height is 450 mm. So it is 450 GL plus 450 they have taken, no? 450 mm, or it is 0.45 meter. Got it? Or it is 0.45 meter. Done, right? So this is that level what they have given. This level they have given it here, that is 100.25. So this RL will be 100.25 here. I hope this much things are clear for you. So all these things will be mentioned in your structural drawings. If you're working in a bigger project, smaller projects, we don't do all these things. Okay. So if I show you the smaller project, this is a smaller project. Here you can see nothing will be mentioned that this is a level and all. For smaller projects, all these things are not required. Only for the bigger projects, we want all these things because we have to carry it, because we'll be having a surveyor for this. So that is why we want. For smaller projects and all these things we don't require. Normally, the contractor, the labor, or the site engineer can take care of this. Yeah. So that site engineer will take care of that, and you don't have to worry about it. Got it? Yeah. So now we'll see the practical application of this, how it has to be understood. Yeah. Now you see it here. This guy has fixed that auto level here, and this is the level. This on the top of this curb stone, you can see, this is a curb what we call that. RL is 98.25. Let us consider how did we get it. So this surveyor might have transferred the level, or usually on the road they are going to write all these things. Okay, now it is 98.25. that is the top of this bund. Now as a surveyor or as a site engineer, how do you take the level? We always HI stand for height of the instrument. So what this height of the instrument I want to find now. So height of the instrument will be RL plus staff reading. That means RL is already known to us, 98.25. That will be written here. Okay. And why I have taken 98.25 here? Because if I go back, so here we had taken 98.25, isn't it? This temporary benchmark what we had set up in our particular project. So that is why I consider 98.25. You can consider anything, whatever is there on your side. But here for our understanding, I've taken this top has 98.25. Let us consider. Okay. Then right. So which is equal to RL. It is 98.25. This will be given plus staff reading. Now let us say I am seeing through this, and I got a reading on the staff which is 2.2 meter, which reads 2.2 meter. So height of the instrument will be 98.25 plus 2.2. It is going to give me 100.45 meter. So this is my height of the instrument which I require to take my level in the next part. Now I want to find the excavation depth level with the help of auto level. How do I do that? So usually whenever we work in the construction project, they are going to give us something called as floor finish level. That is the finishing level where you are going to get. Again, this thing will be mentioned in the structural drawing. If I show you again, you can see it here. GL plus 450 we have taken. That is 100.25. So from this level only, I'm going to take all my reference. That is why I have considered this as 100.25. In some other project, this may be like 100.56, or let us say 101.60, whatever it may be. We are going to take this GFL level. That is a ground finish level that we are going to take. It is 100.25, right? I hope this much things are clear for you. So that is the level what I have written it here. So FFL level 100.25. Now let us say from here to here, that is a depth of excavation. In the structural drawing, they have given it as 3.2 meter. In our drawing, for example, here in this particular drawing, how much they had given for us? They had given it as 1.5 meter, isn't it? 1.5 meter. Let us consider it is not 1.5 meter for time being. I'll make this as 3200 mm. Yeah, 3200 mm. Okay, got it. Now let us say for this particular footing only I'm doing, from here natural ground level to the bottom of the PCC, it is 3200 mm. Okay. Now what I'm supposed to do? I've taken the same thing here. So it is 3.2 meter from here to here 3 point. And this is the thickness of a PCC, which is 75 mm. Okay. This much you have to understand. This is the thickness of a PCC. Again, it will be mentioned in the drawing, which is 75 mm. And let us say the depth of the foundation is 450 mm. The depth of the foundation is 450 mm. So the excavation level, I want to find this bottom level of the excavation. How do I find this? I know this is 100.25. This red line is 100.25. Minus 3.2 is going to give me this bottom level. Minus 3.2 is going to give me this bottom level. You can see this bottom level. Yeah, this bottom level, I'm going to get 97.05. That is 100.25 minus 3.2 will give me 97.05. This much I have understood. This much is understood. Next, height of the instrument we already got from the previous slide. That is RL plus staff reading 98.25 plus 2.2 meter, which comes out to be 100.45 meter. Got it? This much is clear. Now, just to get the staff reading, what I'm supposed to do, this 100.45, this 100.45 minus 97.05 is going to give me 3.4 meter. Now, this is a staff reading that I'm supposed to get when I keep my instrument. What I'm trying to tell is, let us consider I was standing here. Let us consider I'm standing here. Okay, and I fix my instrument here. This is my instrument. Okay, and this is my instrument here. So I want to get a 3.4 meter. When I do the excavation, I'm going to make use of the leveling staff. Anyhow, in the next lecture, I'll explain you in a more better way. So when I keep my staff reading, when I keep my staff, okay, leveling staff here, when I keep my leveling staff at this bottom, and when I try to see through this auto level here, the staff reading has to read 3.4 meter, 3.4 meter. If the staff reading reads 3.4 meter, then I can say that I have done excavation of exactly 3.2 meter. Just in case if my staff reading is not 3.4 meter, let us say if my staff reading is coming 3.2 meter, that means I have done a little less excavation because I wanted 3.4. I'm down by 200 mm. I'm less by 200 mm. So again, I have to do another 200 mm of excavation, and then I have to test it again, right? So I hope you understood up to here, at least the basic part, what it has to be done and all. So in the next lecture, I'll explain you how this has to be practically applied on the site. So we'll see you back in the next lecture. Thank you.